Now we will come to the point expression of intensity. Here in Young's double-slit experiment, when the sources are separated by distance small d apart and the source and the screen are separated by distance capital D, consider two interfering sinusoidal waves. X1 is equal to A1 sine of omega t and X2 is equal to A2 sine of omega t plus delta are superimposing each other, and these two waves having a phase difference of delta. After superposition, the resultant wave becomes x is equal to x1 plus x2, and after doing this we will get this expression. Now consider A1 plus A2 cos delta is equal to R cos theta and A2 sin delta is equal to R sin theta. Substituting these two, we can get the expression of displacement x is equal to R sin omega t plus theta, where R represents the amplitude and R is equal to a square A1 square plus A2 square plus 2A1 A2 cos delta. We know the intensity is the square of the proportional to the square of the amplitude, so I is equal to, we can write A1 square plus A2 square plus 2A1 A2 cos delta. If A1 is equal to A2 is equal to A, then R square becomes 4A square cos square delta by 2 after mathematical calculations. Thus the intensity is I is equal to 4A square cos square delta by 2, where A is the amplitude of the waves and delta is the phase difference. Now come to the condition of constructive interference and destructive interference. Constructive interference means bright fringes and destructive interference means dark fringes. Now cos delta, its maximum value is 1. So it is the value we will get 1 for cos 2n pi. Thus delta is equal to 2n pi, where n is equal to 0, 1, 2, 3, etc. And its corresponding path difference is n lambda. So constructive fringes or bright fringes will produce, constructive interference will occur or bright fringes will produce when delta is equal to 2n pi, where n is the 0 integer numbers, 0, 1, 2, 3 natural numbers, and path difference is n lambda. For destructive interference, the minimum value of cos delta is -1, so this becomes cos is equal to 2n plus 1 pi, thus delta is equal to 2n plus 1 pi, n is equal to 0, 1, 2, 3, etc. And its corresponding path difference is 2n plus 1 lambda by 2. As you know, path difference is equal to 2 pi by lambda, phase difference is equal to 2 pi by lambda into path difference. The ratio of the maximum to minimum intensity is Imax to Imin. Imax is equal to cos delta is, if it is 1, then this value becomes A1 plus A2 whole square, and Imin is equal to cos delta -1 means A1 minus A2 whole square. If we plot the intensity distribution pattern, it will be like this. This is the, at delta is equal to 0, we will get this one is equal to maximum, and delta is equal to, again when it is pi by 2, cos pi by 2 means 0, again cos pi means 1, cos 3 pi by 2 means 0. So this is how dark fringes and bright fringes will produce. So our next question is, if it is bright fringe, it is a dark fringe, then whether the energy is conserved or not during the interference phenomenon. So come to this point, energy conservation. So Imax is equal to, the formula is A1 plus A2 whole square, and Imin is equal to A1 minus A2 whole square. So I average is equal to Imax plus Imin by 2. So this is equal to A1 square plus A2 square. So when there is no interference, I is equal to I1 plus I2 is equal to A1 square plus A2 square. Thus the energy is conserved. Actually in interference phenomenon, energy never be created nor destroyed. Energy is only redistributed from bright fringe to dark fringe or dark fringe to bright fringe. That means energy redistribution will occur. There is no destruction of energy or no creation of energy. There is only redistribution from bright to dark or dark to bright. Next part is fringe width. What is fringe width? Separation between two consecutive bright and dark fringes is known as the fringe width. Separation between two consecutive bright or dark fringes is known as fringe width. If we come to this, to the previous slide, we can see these are the bright fringes, this is the dark fringes. So separation between these two, so bright to dark, bright to bright, consecutive to bright means this is the fringe width. This is the fringe, this part is the fringe width. Again, this one is the fringe width, this one is the, even similarly, this is the fringe width of the bright fringe. Distance between two consecutive bright or dark fringes is known as the fringe width. Now, how we can find out the thickness of a thin transparent sheet, generally mica sheet? Consider when the light is coming from S1 and S2 and it is coming to point O, then there will be no path difference. It will produce a bright fringe or constructive interference will occur. Now, along the direction from the light from S1 to O, a mica sheet of refractive index mu and thickness T is placed. What happened? Now, the bright fringe that is produced at point O, it is now shifted to the point P. Shifted to the point P at a distance of widest from the central fringe. Now we can calculate from the concept of velocity of light, we can find out the thickness of this one. Now, after the calculations, the thickness becomes T is equal to n lambda mu minus 1. This n lambda comes from condition for the bright fringe and mu minus 1. Alternatively, we can write T is equal to y dash lambda beta mu minus 1, or beta is equal to lambda capital D by small d is a fringe width. So this is how, if we know the value of the refractive index of the mica sheet or any transparent sheet, and the wavelength of light used, we can measure y dash from the telescope, and beta that can be easily calculated as we know the wavelength of the light used. D and capital D and small d can be measured. So you can find out the value of T. T is the thickness of the mica sheet. Now, interference of thin films, that from the very beginning we have discussed during the we have mentioned actually, not discussed, mentioned actually during the soap films or water film on oil or oil film on water. We have discussed this thing. So thickness, this is the, suppose this, there are two planes separated by thickness T. When light is coming from A to B, one part of light is reflected, another part is transmitted. Again, this light is reflected from C, then refracted. Again, this part from D is reflected, then reflected. From E, some light is transmitted, from C, some light is transmitted. So when the light coming from this path A, B, R1 and A, B, C, D, R2, there is a path difference. There is a path difference. These two lights R1 and R2 are from reflected light. This path difference is Bn. There is a path difference Bn. So when there is a path difference, there will be a condition, either it will produce bright fringe or dark fringe. There is a phase difference definitely. Depending upon the path difference, phase difference will produce. Either it will produce bright fringe or dark fringe. Another one, for this transmitted lights T1 and T2, there is also a path difference. This one is Ck. So for this transmitted light, there is also bright fringe and dark fringe. So interference can produce by the two methods. One is by reflection, another one is by transmission. So we can calculate the path difference between the two reflected rays R1 and R2 is 2 mu T cos R. This is the angle R, plus minus lambda by 2. This plus minus lambda by 2 appears due to change in medium. This one is air, this one is a medium. That's it. There is a one term plus minus lambda by 2 is applied. So for constructive interference, this path difference is equal to n lambda. So you can write 2 mu T cos R is equal to 2n plus minus 1 lambda by 2. For destructive interference, the condition will be 2n plus minus 1 lambda by 2. So lambda by 2 will cancel out. This one becomes 2 mu T cos R is equal to